Quiz 36. Determine the amount of energy required to melt 5 pounds of ice at 0 degrees Celsius. Well, we're already at the melting point, so all we need is delta Q is equal to mL sub F, the latent heat of fusion. And so the delta Q then is our mass. Let's see, we have 5 pounds, so we have to find the mass. There are 2.205 pounds in 1 kilogram. And there are 1,000 grams in every kilogram. Then we have to put in our latent heat of fusion, which is 333 joules per gram. Now all we have to do is calculate it. And so we're going to get 5 divided that by 2.205 multiplied by 1,000 and multiply that by 333. And we're going to get 755,102, 755,102, and the units are joules. 755,102 joules, about 755,000 joules. Okay, an unknown metal has a mass of 32 grams and releases 365 joules of energy. Identify the metal. Well, as it solidifies, we're going to go through the latent heat of fusion. So we have delta Q is equal to mL sub F. So our amount of energy released is 365 joules. And the mass is going to be 32 grams. And so the latent heat of fusion, we just have to solve for that. And so what we're going to get is 365 divided by 32. And we get 11.4 joules per gram. Now this is the latent heat of fusion, so we have to go to the data table that you have on the latent heat of fusion and the latent heat of vaporization and find out what material has this specific latent heat. So when you look that up, you'll find that that is the latent heat of fusion for mercury. A sample of gold has a mass of 50 grams and an initial temperature of 720 degrees Celsius. Determine the energy required to melt the sample. What we need to do is bring the sample up to the melting point, and then we have to go through the melting point. So we're going to have delta Q is equal to mc delta T. That gets us up to the melting point. And then we have to add mL sub F because we have to melt it. So our total energy, delta Q, is the mass, which was 50 grams. And now we have to use the specific heat of gold. And the specific heat of gold is 0.129 joules per gram degrees Celsius. And now we have to find the melting point for gold. And so the melting point for gold is 1063 degrees Celsius. And we have to subtract the initial temperature of 720 degrees Celsius. And then we have to add the amount of energy it takes to go through the melting, which is 50 grams, times the latent heat of fusion for gold, which is 64.4 joules per gram. Now we just have to calculate this. And we're going to get 50, multiply that by 0.129, multiply that by quantity 1063 minus 720, and then what we have to do is add 50 times 64.4, and we're going to get 5432. 5432, and the units are joules. So we have 5430 joules. A sample of silver has a mass of 50 grams and initial temperature of 720 degrees Celsius. Determine the energy required to melt the sample. Okay, it's the same problem, but we're going to do it with silver this time. So we're going to have delta Q is equal to mc delta T and then plus mL sub F. And so our delta Q then is going to be our 50 grams, but now we need the specific heat of silver, which is 0.234 joules per gram degree Celsius. The final temperature, we need to know the melting point of silver, which is 961 degrees Celsius, and you find this on that data table that I provided for you. minus 720 degrees. And then we have to go through the melting point, so that's our 50 grams multiplied by the latent heat of fusion, which is 88.2 joules per gram. So let's calculate it. So we're going to get 50 times 0.234 times 961 minus 720 plus 50 times 88.2. So 7230 joules. 7230 joules. Sample of iron has a mass of 50 grams and initial temperature of 720 degrees Celsius. Determine the energy required to melt the sample. This is the same problem, just a different substance. So we have delta Q is equal to MC delta T plus ML sub F. And so we have delta Q then is our 50 grams. And now we have to look up the specific heat of iron. Now the specific heat of iron is 0.448. And that's joules per gram degrees Celsius. And we need the melting point of iron, which is 1538 degrees Celsius minus the 720 degrees Celsius, because that's where it is initially. And then we have to go through the actual melting process, which is 50 grams times 247, 247 joules per gram. All right, so we have 50 times 0.448 times quantity 1538 minus 720, and then we have to multiply 50 by 247. So 50 times 247, and we're going to get 3673. 3673 joules. So that's about 30,700 joules. About 30,700 joules. Determine the amount of calories required to vaporize 10 grams of water at 100 degrees Celsius. So now we're at the boiling point, and all we want to do is vaporize the water. So we want to go through that latent heat. But this time, it is the latent heat of vaporization. And so we have the mass, which is 10 grams, and we have to look up that latent heat of vaporization, which is going to be 2260 joules per gram. Now the question says also that it wants the number of calories, and there are 4.184 joules for every 1 calorie. So let's calculate that. And so we have 10 times 2260, divided that by 4.184, and that gives us 5402 roughly. Calories. 5402, so 5400 calories. Determine the amount of kilocalories required to vaporize 10 grams of water at 70 degrees Celsius. Now we have to bring the water up to the boiling point and then vaporize the water. So we're going to have a delta Q is equal to an MC delta T plus an ML sub V. So how much water are we going to use? 10 grams. What is the specific heat of water? It is 4.184, and that is joules per gram degrees Celsius. The final temperature is going to be 100 degrees Celsius minus the initial temperature of 70 degrees Celsius. Then we have to add in the vaporization component, so that's 10 grams. Multiply that by, look up the vaporization of water, it's 2260. 2260 joules per gram. All right, so that's a lot of stuff. So let's go ahead and calculate that. So we have 10 times 4.184, multiply that by 30, and then we have to add 10 times 2260. And that's going to give us 23,855. So 23,855 855 joules. Now the question says it wanted kilocalories. So there are 4.184 joules in a calorie, and there are 1,000 calories in 1 kilocalorie. So we have to divide that by 4.184, and then we have to divide that by 1,000. And that gives us 5.7 kilocalories. 5.7 kilocalories. Determine the amount of calories required to bring 10 grams of ice at 0 degrees Celsius to a temperature of 25 degrees Celsius. Okay, it's solid ice, so we first have to melt it, and then we have to raise the temperature. So delta Q is going to be M, and we have to melt it, so that's the latent heat of fusion, plus our MC delta T. So what we have is we have 10 grams, and the latent heat of fusion for ice is 333 joules per gram. And then we have to add to that our 10 grams because we're going to raise the temperature. So 4.184 joules per gram degrees Celsius. That's the specific heat of water. And the temperature, the final temperature is 25 degrees Celsius. The initial temperature, it's at its melting point of water, 0 degrees Celsius. Let's calculate it. So we have 10 times 333 plus 10 times 4.184. Multiply that by 25. We get 4376 joules. And our question wants to know calories. And you'll see that it is a big calorie, a capital C. So that is a kilocalorie. So we have to remember that. 4.184 joules for every 1 calorie. And there are 1,000 of these small calories for every 1 of the large calorie. All right, so we divide that by 4.184, and then we divide by 1,000, and that gives us 1.046. 0.046, and then that'd be capital calorie. So 1.046, 1.05, that's close enough. A 50-gram sample of water with a temperature of negative 15 degrees Celsius absorbs 25 kilojoules of energy. Determine the final temperature of the water. All right, it's at a negative 15 degrees Celsius, and it absorbs 25 kilojoules of energy. So what we're going to do is we're going to add energy to get ice up to its melting point. And then we're going to melt the ice, and then we're going to raise the temperature further to see what the final temperature will be. So we have delta Q is equal to an MC delta T. Then that's going to get us up to the melting point. And then we have to add energy, the latent heat of fusion, in order to melt the ice. And then we're going to raise the temperature a little bit more. And we're solving for the final temperature that we get. So our delta Q is 25 kilojoules. So we have 25 kilojoules. So there are, in each kilojoule, there are 1,000 joules. And then that has to equal the mass, which was 50 grams, multiplied by the specific heat of ice, which is 2.09 joules per gram degrees Celsius. That is the specific heat of ice. And then we have our final temperature, which is going to be the melting point of ice at 0 degrees Celsius, minus the temperature that it's at, which is a negative 15 degrees Celsius. Put a little parenthesis around there. And then we have to go through the melting point. And so we have to melt that ice. So mL sub F, so that's 50 grams. Multiply that the latent heat of fusion, which is 333 joules per gram. And then we have to raise the temperature further. So we have that MC delta T, 50 grams. The specific heat of water is 4.184 joules per gram degrees Celsius. And then the final temperature we don't know, and the initial temperature is 0 degrees Celsius. So all we have to do is solve. So we have 25 times it by 1,000 equals 25,000. And we're going to subtract off, let's see, that's going to be 50 times 2.09 times 15. And now we're going to subtract off 50 times 333. All right, now we have to divide by 50 and divide by 4.184. Now I get 32.4 degrees. 32.4 degrees is our final temperature. Now, however you want to plug that into your calculator and solve, you go right ahead. You don't have to solve it the way that I have, but the steps are all there, and the solution is there, and hopefully you completely got it. So keep after it, and best wishes.